Static electricity can cause certain materials to exhibit strange behavior, such as gravity defiance and seemingly unprompted motion. It all results from the behavior of the tiny negatively charged electrons in the atoms that make up matter. If a material has an overall excess of electrons, it is said to be negatively charged, while a lack of electrons is considered positive. An important rule is that like charges repel, while opposite charges attract. So negative and positive charges will be drawn towards one another, while positive and positive will repel, and negative will repel. A good demonstration of electrostatic attractions is when you rub a plastic ruler with a wool scarf. As the two are rubbed together, electrons in the atoms of the wool are transferred to the atoms of the ruler. Therefore, the scarf has a net positive charge from the loss of electrons, whereas the ruler has a net negative charge because of the excess electrons. Now, when you move the ruler towards the scarf will be drawn to the ruler since opposite charges attract. If you let the two touch, this will allow the electrons to travel from the ruler and back to the scarf. If you charge the ruler with the scarf and bring it to some pieces of paper, you will see a similar phenomenon. In this case, the pieces of paper are neutral in charge, but the negative charge of the ruler induces a dipole moment in the papers, where the sides closer to the ruler become more positive, because the electrons in the atoms of the paper are drawn away from the ruler. There's no net change in charge on the paper, it's just that one side has less negative charge than the other. This is called charging by induction, when the two objects gain opposite charges without touching. If you induce a charge on an object connected to the ground, then the object can gain a net charge, as the electrons can freely flow down into the earth. When a neutral object and a charged object do come into contact with one another, the electrons flow from one material to the other, and eventually the two objects gain the same charge. This is called charging by conduction. Here we can see that the pieces of paper are light enough that they actually fly up and stick to the ruler. You can also see some charge repulsion when you draw the ruler towards the papers, because some of the papers have positively exposed sides very close to one another, so these repel and the papers fly away from each other. The materials used are important in these experiments because some substances transfer electrons easier than others. In the case of the plastic ruler, the plastic atoms hold onto their electrons more loosely. Therefore, the ruler can experience greater charge fluctuations, whereas repeating the same experiment with a wooden ruler doesn't have the same effect. Water is an interesting substance because overall its molecules are neutral, but it has a polar quality that gives it many unique characteristics. Its oxygen atom has a higher electron density than the two hydrogens, giving it a bent shape, and one side that's more negative and one side that's more positive. For instance, if you charge a plastic ruler and bring it near water, the water molecules orient themselves so that the positive ends are more near the negatively charged ruler. This is why higher humidity levels reduce static electricity. The water molecules are conductive and they absorb more charge, which reduces uneven distributions of charge in the air. These experiments demonstrate the concept of the conservation of charge. Basically, in any process, the net amount of electric charge created is zero. In other words, no net electric charge can be created or destroyed. Either electrons are moving from one material to another, giving a negative charge to one object and leaving the other with a positive charge, or electrons remain in the atoms of a material, but they just orient themselves in a certain way in the atom so that they're nearer to a positive charge.